You ever try to fix a problem and somehow you only end up making it worse? We've all been there. Well, today we're going to dive into two really powerful ways of thinking that help you get to the real root of those stubborn issues. We're going to learn how to see the entire playing field and how to predict the moves of everyone on it.
So let's just start with a question that is, I think, frustratingly familiar to all of us. You see a problem, you come up with what seems like a brilliant, totally logical solution, you put it into action, and then you just watch as it completely backfires, sometimes making the original problem even worse. Why on earth does this happen so often?
Take traffic, for example. The logical plan seems obvious, right? If the roads are jammed, just build more roads. It makes perfect sense on paper. But the reality, as city planners have learned the hard way over and over again, is that more highways often just encourage more people to drive, filling up those brand new lanes and leaving you right back where you started, stuck in traffic. Now, this isn't just a string of bad luck. It's actually a classic system trap. It's a phenomenon often called shifting the burden. This is where a really well-intentioned fix only deals with the symptom, the traffic jam, while completely ignoring the root cause. And sometimes it actually makes the underlying problem even weaker. It's like putting a little Band-Aid on a really deep wound. Okay, so to break out of this trap, we have to fundamentally change how we see the problem. And our first tool for that is something called systems thinking. This is what helps us map out the invisible structures and all the relationships that are really driving the problem in the first place. It's about zooming out from just one car in a traffic jam to see the entire transportation system as a whole. So what is it exactly? Well, think of it like putting on a new pair of glasses. Instead of seeing a world of separate, disconnected things, you suddenly start to see the connections, this intricate web that holds everything together. You start to realize that every single action creates ripples, and those ripples almost always come back around, often in ways you would never expect. All right, so at the very core of any system is something called a stock. And don't let the name fool you, it's a simple idea. It's just an accumulation of something over time. It can be something physical, like the population of fish in the ocean, or the money in your bank account. Or it can be totally intangible, like your level of stress or a company's morale. And the easiest way to picture a stock is just to think of the water level in a bathtub. And that water level, the stock, it can only be changed by two things. You've got inflows, which is the faucet pouring water in, and you've got outflows, which is the drain letting water out. So for our fish population, the inflow is births, and the outflow is deaths, and of course, fishing. For your bank account, it's deposits and withdrawals. Super simple, right? But this is where it starts to get really interesting. So you have to ask what's controlling the faucet and the drain. The answer is feedback loops. These are the powerful hidden engines of any system. This is where a change in one thing, like that water level, feeds back to cause even more change, creating these powerful, vicious, or virtuous cycles. And what's really incredible is that almost all of the complex behavior you see in the world is driven by just two kinds of loops. First, you've got reinforcing loops. These are the ones that amplify change. It's the classic snowball effect. More money leads to more investment, which leads to more money. Then you have balancing loops. These are goal-seeking. They resist change to keep things stable, just like how a thermostat keeps your room at the right temperature. But here's the thing. A system's structure, all its pipes and drains and loops, that's only half the story. Because that system is filled with people, and those people are making decisions. So now we need to shift our focus from the game board itself to the players who are moving the pieces. And for that, we turn to our second amazing tool, game theory. Basically, it's the formal study of decision-making in situations where the outcome for you depends entirely on the choices made by other people. You could just call it the science of strategy. This quote from William Spaniel just sums it up perfectly. We are talking about any situation where my best move depends on your best move, and your best move depends on mine. From a simple game of chess to complex international politics, this kind of strategic interdependence is absolutely everywhere. And this brings us to probably the most famous puzzle in all of game theory, the prisoner's dilemma. Here's the setup. Two partners in crime get caught. They're interrogated in separate rooms. If they both stay silent, if they cooperate with each other, they both get a light sentence. But if one of them rats out the other, defects, the defector walks free while their partner gets a really long sentence. And if they both defect on each other, they both get a medium sentence. So here's the dilemma. No matter what the other person does, It is always in your own individual best interest to defect. But when both players act rationally and do that, they both end up in a much worse situation than if they had just trusted each other and cooperated. Okay, so let's bring these two incredible ways of seeing the world together. We're going to use a famous problem that really reveals the power of seeing both the system and the game at play. It's called the tragedy of the commons. So imagine a public fishing ground. It's a shared resource, a common stock of fish. Every single fisherman wants to maximize their own profit, right? So the individual incentive is to catch as many fish as you possibly can. But what happens when everybody starts thinking that way? First, let's put on our systems thinking hat. More boats in the water means a higher harvest, which obviously reduces the stock of fish. But here's the kick. Fewer fish also means slower reproduction, a smaller inflow to the stock. This creates a terrifying reinforcing loop, a death spiral, where all that short-term success guarantees the long-term collapse of the entire fishery. Now, let's switch glasses and look at it through the game theory lens. This is just a huge multiplayer prisoner's dilemma. For any single fisherman, the rational choice is always to overfish. I mean, think about it. If the other guys conserve, you get the biggest catch. And if the other guys overfish, well, you better grab what you can before it's all gone. So a series of perfectly rational individual choices leads directly to collective ruin. So now we have a really clear diagnosis. The system itself is wired for collapse, and the incentives of the game pretty much guarantee it happens. Now, for decades, most people thought there were only two solutions to this, either total government control or complete privatization of the resource. But it turns out they were wrong. And this is where the absolutely brilliant work of Nobel laureate Elinor Ostrom comes into the picture. She spent her career studying communities all over the world that had successfully managed these common resources for centuries. And what she found was that they didn't need some big, top-down authority to save them. They figured out how to solve the problem themselves by fundamentally changing the rules of the game. So how do they do it? Well, it was through these elegantly simple, deeply human solutions. They used face-to-face communication to build up trust. They created clear, shared rules that everyone agreed to. They monitored each other, and they had graduated penalties for anyone who broke the rules. Now notice what they're doing here. They aren't just tweaking the individual payoffs. They are redesigning the entire system of how they interact with each other. So what is the big takeaway from all of this? To solve our most complex, our most stubborn, backfiring problems, we really need both of these perspectives. We need to be systems thinkers to map out the invisible structure, the stocks, the flows, the feedback loops. And we need to be game theorists to understand the strategic incentives that are driving the players inside that system. You have to be able to see the whole board and anticipate the next move. And that leaves us with one final question for you to really think about. What is an unwinnable game in your work or in your community or even in your own life? And what do you think would happen if, instead of just trying to play that game better or harder, you focused on changing the rules of the system itself?